Assalamualaikum. I hope all of you are in a good condition at home. So, today we will learn about the refraction of light. Before that, I want to show you one phenomena that happened because of refraction of light. So, can you see this? The straw in the water. Right. So, the straw in the water is not in a straight line. It is because of the phenomena of refraction of light. So, our lesson today is refraction of light Form 4 KSSM. Alright, so before we start our lesson, I want to tell you about the learning outcome. The learning outcome first is describe refraction of light. Second, explain refraction index. And third, apply the conceptual Snell law. Alright, so for the learning emphasis, student will be able to define the refraction of light. Student also can compare the refraction of index of different medium such as air, water, oil, gas and diamond. Next, student can solve problem of the refraction index by using formula, and last but not least, solve the problem of the refraction of light that state from the light traversing between two medium. Okay? Alright. So, as the example I showed before that, what is the refraction of light? Anyone want to answer? Yes, Camilla. Okay, Camilla said that a refraction of light is a bending of light. Yes, it's very true, but it's not complete. You have to state that if the refraction of light is the bending of light ray at the boundary of two medium as the light ray propagate from a medium to another medium with different optical density. The keyword here, when the question asks you what is the refraction of light, you have to state that bending of light ray 1 point, propagates from medium to another medium 1 point, and different optical density is 1 point. Here you can get 3 points if the question stated that 3 points, but if you write in the full sentence, you can also get a full mark. Alright. So, to further our understanding, you have to remember this theory or concept of the refraction of light, which is light passing into an optical denser medium is bent towards the normal line. So after this, I want to show you what is the normal line, what is the term used in the refraction of light topic. So you have to remember that light passing into the optical denser, meaning the medium more denser, like the oil, diamond, glass. That's the example of the medium, the denser medium of the material. So it's bent towards the light, bends towards the normal. Light bends towards the normal. You have to remember that. But if the light passing into the optical less denser, what's the example of less denser? For example, less denser is water, air. That is the medium for the less denser. So light will bend away. Light will bend away from the normal line. Okay. Okay, this is the example or more diagrams to you to more understand lah. So for the refraction of light, when this is the incident ray, which is the light from the sunlight or from the source, which is for example, another example, the lamp So incident ray, and when the pass through to the another medium, it will be refracted ray. So this is the normal line, which is the point between the incident ray and refractive ray. This is a medium 1, which is air, and medium 2, which is block. Alright. So what is I? What is R? I is the angle of the incident ray, and R is angle of refracted ray. So you have to remember that the one we are looking forward is the angle of the refracted ray. You have the keyword before I state to you, which is when the medium less denser, which is from the less denser to denser, the refracted ray will be towards the normal line. But when the medium is denser to less denser, the refracted ray will be away from the normal line. Away from the normal line. So you can see that the refracted ray towards the normal line, but the refracted ray when the glass block to air, which is denser to less denser, the angle of refraction or the refracted ray will be away from the normal line. So I hope you can get the concept or the theory of the refraction of light. Okay, let's do the simulation. With that, are you understand about what I want to talk about? Alright, thank you. So I hope you all are focused, because after this we will do the exercise on the past examination paper. Alright, so let's do the simulation. Okay, this is the simulation. So you can see that the material is air, and the second material is glass. So air is less denser than glass. So when I open the light, so you can see that the reflected ray is towards the normal line. Reflected ray towards the normal line. But when I get different material, which is from the denser to less denser, for example, I use glass, and the second one I use water. You can see that the reflected ray is away from the normal line. Away from the normal line. So here, from the less denser to more denser, it's towards the normal line. But when it's denser to the less denser, it's away from the normal line. Okay? Alright. So we move to refractive index. So what is the refractive index? Refractive index is the difference, determines the degree to which the light bends when traveling from vacuum to a medium. So we know that from vacuum is no gravity, right? So we also can define that refractive index as the ratio of the speed of light in vacuum to the speed of light in medium. So the refractive index, when the question asks you to find n, so you have to use the n equal to C over V. Or the second formula you have to remember, when the question asks you about the refractive index and you have the angle of incident ray and angle of refractive ray. So what you have to use? You have to remember this question, this formula, n equal to sine I, which is I is the incident ray, divided by sine R. R is the refracted ray. Alright, so you have two equations, 1 and 2. Okay, you get it? Alright, so Snell law. What is Snell law? Snell law is the law of refraction, and how we can determine the Snell law. Okay, Snell law is the incident ray, the refractive ray, and normal meet at one point and are at the same phase. Alright, for example, you have a glass and light passing into the glass from air to glass, so it will be away from the normal line. Alright, away from the normal line. Okay, the point is they meet at the one point, which is this point. So we can say that is the law of refraction. Alright, so what is the formula for this Snell law? So for all I want to call Aisha. Do you know what is the formula for Snell law? No, it's not true. So here I want to clarify all the formula. So Aisha said the formula is n sine theta 1, but it have compared two medium. So n1 sine theta 1 equal to n2 sine theta 2. Alright, Aisha only state the one medium, but we have to compare between two medium. Whereas n1 is a medium 1, theta 1 is a angle of incident ray, n2 is a medium 2, and the sine theta 2 is the angle of refracted ray. Alright, so I hope you clear. It's not only one n1 as sine theta 1, but we have to compare between two. That is the Snell law of refraction. So I hope you clear. Alright, let's do an exercise to strengthen our understanding. Alright, so for this question, I want you to read the question one or two times to you to more focus on what the question asks. Alright, so for this, find the refractive index, and for the perspex. So where is perspex here? So we know that we don't have a n2, right? N2, we don't have n2. We don't have n2. Alright, so before this, I state that there are many ways to find n's, right? So which is n equal to c over v, n equal to sine I equal to sine r. But here the clue is it given us two medium, right? Two medium. As I mentioned before, if the question give you two medium with angle, you have to use the Snell law. So let's do together. Okay, I want to give you 5 minutes or 3 minutes because the question is too straightforward, and I want to call someone. Okay. Yes. Yes, Yana? Okay, let's find that your answer is true or not. So, we have to write down the formula. So, N1 sine theta 1 equal to N2 sine theta 2. Okay? N1, we know that N1 is 1.33. So, sine theta 1 is 50. N2, what we find? And sine theta 2 is 42.8. Okay. Put all the information you come out with into the formula. Okay, N1 is 1.33 sine theta 1 50 equal to N2, what we find? Sine theta 2 42.8. So the answer is 1.50. So Yana's answer is correct. Congrats, Yana. Well done. You understand what I focus on. So let's focus on the examination paper, which is very important for you to understand in this chapter. It is easy topic, right? So I want you to get a full mark and never do a mistake. Okay? Negeri Pahang for the trial. So diagram 3.2 shows the sound wave produced by a boy sings at the distance to his can. So based on diagram 3.2, calculate the refractive index. So refractive index here is N. So if you don't know how to choose the right formula, come out with all formula that you remember. So we have 1N equal to C over V, N equal to sine I over sine R, and we have Snell law, N1 sine theta 1 equal to N2 sine theta 2. So here we know that we have the incident ray and refracted ray. So here we have to use the second question because it has the angle of incident ray and angle of refracted ray. So N equal to sine I bagi sine R. So anyone want to answer? Yes. Yes, Atika. The answer is 1.13. Yes, correct. Thank you. So the answer is 1.13. So, do you understand what I'm talking about? Alright, thank you. So let's try another trial or examination paper. So the diagram below show a light ray travels from medium to end. We don't know what is a medium, right? But here is the clue, medium to air, but we don't know what is a medium. Alright, we don't know the denser medium or the less denser medium. So what you have to do is you have to look at the refracted angle or ray. Okay, when you see that the refracted ray is away from the normal line, which is the medium is from denser medium to less denser medium, from denser medium to less denser medium. Alright, so calculate the reflective index of the medium to air, which is we can use the index, the Snell law. We can use the Snell law, or we use the n equal to sine I over sine R. But here I want you to use the law of refraction because of the marks. You can see that the marks is 3 marks. So that the question asks you to find the Snell law. So Snell law, first write the formula. N1 sin theta 1 equal to N2 sin theta 2. Okay. Okay, we know that the air is 1.00 for the medium. So N1 we don't know the refractive index because of we don't know what is the medium. So we don't know. Theta 1 we know is 35, and 2 we know is 1.00, and theta 2 we know that 68. Okay, put all the information given into the formula. So N1 we don't know, sin 35 equal to N2 1.00 sin theta 2 68. So anyone to answer? Let's do it together, right? So, anyone get the answer? Yes, Yana. What's your answer? 1.62. Yes, correct. 1.62. Congratulations. I hope I can see that all of you understand how to formulate the calculation, how to use the formula, and I hope you understand the concept, because the concept will ask you on a paper 1 or on a definition. So from the definition, you can state it with the concept that you understand. Alright. So summary of the lesson today. I show you the phenomena of refraction of light. So I hope you know the refraction of light, the phenomena of refraction of light, which is the straw is not in a straight line in the water, or if you are doing another experiment, you can see that there are many refractive phenomena in this world. So I hope you can read in your textbook, because your textbook is very important for you to get an idea and example to you to use in your examination. Next, we have the index of refraction. There are 2 index of refraction, n equal to C over V. C is the light, the velocity of light, which is 3.0 equal to 10 power of 8, and V is velocity of the light passing through the medium. Alright. So law of refraction, which is sin N1 sin theta 1 equal to N2 sin theta 2. Alright. N1 sin theta 1 equal to N2 sin theta 2 when the question asks you between two medium. Alright, two medium. And last but not least, calculation based on situation. When it gives you the two angle of refraction, you use N equal to sin I divided by sin R. Alright. Three formula you have to remember. One, N equal to C over V. Second, N equal to sin R over sin R. And third, N1 sin theta 1 equal to N2 sin theta 2. Alright, so here homework for you to do, and I will check on the Google Classroom. Send it on the Google Classroom. So don't worry, I just put it on your Google Classroom. So remember, do it, and the due date for this homework on the Tuesday. I want to see on Tuesday. Alright, all of you. So thank you. I hope all of you know how to use the formula. It's very important for you to focus on your examination. I hope all of you get enough sleep, do your study, and don't remember to eat well. Alright, it's very important for your mental health and your condition. I think we meet on another class. Thank you for leading me your ears, and have a nice day. Thank you.